For the given system of linear equations, we want to solve using Gaussian elimination and then backward substitution. So when we're talking about solving using Gaussian elimination, our goal is that we can write this system as a matrix and then turn that matrix into row echelon form, or REF. So if we've done that successfully, we will have ones on the diagonal of our matrix. We will have zeros down below that diagonal, and then any other numbers in the remaining positions. So what we're going to do is we're going to work our way across, starting with the first column, get that to be 1, 0, 0. Once we have that, we'll move over to the second column and then to the third column. So we'll do it systematically from left to right. So our first step is to take the given system and write it as a matrix. So we're going to take the coefficients and use that to create our matrix. So from the first equation, we're going to take the 1, the 2, the 1, and then our constant of 3. So this is what's called an augmented matrix. So 1, 1, negative 1, and 3, negative 1, negative 2, 1, and negative 5. So as we compare our current matrix to the goal that we're trying to accomplish, the first thing that we need is a 1 in the top left corner, and we already have that, so that position is ready to go. So we're going to continue working in the first column. So the next thing that we're going to focus on is that 1 in row 2. So I would like for that to be a 0 instead. So the way that I'm going to turn that into a 0 is I'm going to take my current row 2 and I'm going to add to it a multiple of row 1 so that it adds to 0. So since row 2 currently has a 1, 1 plus negative 1 would add to 0. So what I'm going to do is I'm going to take negative 1 times the entire row 1. I'm going to add these two together to create a new row 2. So our matrix is still going to have the same first row, and it's still going to have the same third row, but we're going to create a new row 2. So to create our new row 2, we're going to take the current row 2, and we're going to add negative 1 times the current row 1. So row 2 right now is 1, 1, negative 1, and 3. Row 1, multiplying it by negative 1 is going to become negative 1, negative 2, negative 1, and negative 3. And we are going to add these together. So 1 plus negative 1 is 0. That was the whole point of this. 1 plus negative 2 is negative 1. Negative 1 plus negative 1 is negative 2. 3 plus negative 3 is 0. So I'm going to put that in as my new row 2. So this that came out at the bottom is our new row 2. So now take a moment, compare our current matrix to the goal that we were going for. So we still have that 1 in the first position, but now we also have a 0 in the second row. So now we need to work on row 3. It currently has a negative 1, and we want that to be a 0. So I'm going to take my current row 3, and I'm going to add a multiple of row 1. Well, this time row 3 has a negative 1, row 1 has a positive 1, so I can just add those together as is without doing any multiplication to come up with my new row 3. So for now, I'm going to keep row 1, row 2, as is, and I'm just going to work on my row 3. So I'm going to take my row 3 and my row 1, add those together to get a new row 3. So in row 3 we had negative 1, negative 2, 1, and negative 5. And in row 1 we had 1, 2, 1, and 3. I'm going to add those together. So we get 0. That was the goal. Negative 2 plus 2 is also 0. 1 plus 1 is 2. Negative 5 plus 3 is negative 2. So this is going to be our new row 3. So let's compare to our goal. So we have in the first column now 1, 0, 0. That matches exactly with what we said our goal was in our row echelon form. So since column 1 matches exactly with column 1 in our goal, we're going to move over to column 2. We don't worry about what's in the first row in column 2. We need the second row in column 2 to have a 1. Right now it has a negative 1. So we're going to do a multiplication here times our current row 2. So let's move everything up here to have a little more space to write. So I'm focused in on this position on my matrix. Now the reason I want to do a multiplication rather than adding a multiple of row 1 is I don't want to ruin that 0 that I already got in the first position. So if I added some multiple of row 1, it would lose the 0. So I want to keep that. So since I have a negative 1, but I would like to have a positive 1, I'm going to just take negative 1 times row 2 to have a new row 2. So our 1, 2, 1, 3 stays the same in row 1, 0, 0, 2, negative 2 stays the same in row 3. So our new row 2, negative 1 times 0 is still 0. Negative 1 times negative 1 is positive 1. Negative 1 times 2 is positive 2. Negative 1 times 0 is 0. So let's think about our goal. In the first column, we still have our 1, 0, 0. We haven't lost that. In the second column, we have our 1 and our 0. So column 1 and column 2 both are completely ready to go. So we now move over to column 3. We don't worry about the first 2 rows. We just focus in on row 3 in column 3. It's currently a 2. We would like for that to be a 1, but I don't want to mess up those zeros that I already have. So I'm going to use a multiplication again here. I'm going to take 1/2 times my current row 3 and make that a new row 3. So the first 2 rows we just recopy. And now 1/2 times everything in row 3. So 1/2 times 0 is still 0. 1/2 times 2 is 1. 1/2 times negative 2 is negative 1. So look at that matrix. It has 1s on the diagonal and it has the zeros down below. This matrix is in what we call our row echelon form, or a lot of times we just write REF. Once we are in that row echelon form, the reason we wanted this format is that the system of equations that's related to this rewritten matrix is much simpler to solve than the one that we started with. So if we move this up and write out our equations, the 3 equations that go with our matrix would be 1x plus 2y plus 1z equals 3. We have y plus 2z equals 0. And the last equation, since it's 0 for x and 0 for y, is just z equals negative 1. So that's already telling us one of the values that we need in our solution. We can take that negative 1 and plug it into our second equation. So y plus 2 times negative 1 equals 0. If y minus 2 equals 0, then y equals 2. And now use both of these values and plug into that first equation. So x plus 2 times 2 plus negative 1 equals 3. So we have x plus 4 minus 1 equals 3. If x plus 3 equals 3, then x equals 0. So we have found the solution to our original system of equations, that our solution is going to be what we call an ordered triple. We write the x, then the y, then the z. So it's 0, 2, and negative 1. So we keep in mind our goal all the way through. What are we trying to do as we rewrite on each step? That we focus on one column at a time, working our way from left to right across our matrix. Once we have that first column to match up to our goal, then we can work on matching up the second column and the third. And so we're trying to get ones on the diagonal and zeros down below. Once we get our matrix into that format, we write the equations related to our matrix, and those equations can be solved using backward substitution.